Shelby, you asked me a great question. Where did the 142 come from? Fantastic question. I want you to quit out of this screen. And I'm going to pull, just rotate it to the side. And we'll rotate it back when we're done and make it line up again. Let me fix the camera so it's pointing at the right place. Yeah, let's zoom in. What I want to do now is, I want to recalculate this quantity right here, but entirely use the TI. So here's what we're going to do. Everybody, second mode, get back to your home screen. Second mode, back to your home screen. Hit the clear button. Get yourself a nice clear screen. Nice clear screen. Okay, remember that Y1 command I always have you guys using? linreg Y1, quadratic Y1. Vars right, enter, enter. Go get it right now all by itself. Vars, right, enter, enter. Don't push enter again, yet. Right now it says Y1. You can push enter if you want. It looks like it give you an error if you do. So don't.
Wait, what'd you do?
Vars right, enter, enter. Page 4, paragraph 1. Y1. Now, watch this. Everybody, if you would, left parentheses, 10.1, right parentheses. Now press enter. Does that number look familiar? That is the Y value at the X value of 10.1, yes?
Oh.
Oh, yes. Oh, yes. Now, everybody, second enter. If you press second enter, you should get Y1 10.1 back again, yes? Everybody, minus. Okay, so far? Vars, right, enter, enter. You see a second Y1 there now, yes? Left parentheses, 5, right parentheses. Yes, and now go ahead and press enter. Does that number sound familiar? There's your 142. Now, think about symbolically what we just did. Y1 10.1 minus Y1 5. What did it just do? It subtracted what? 200 from 50, or 58 from 200. Yes, good, Kelly. What is Y1 of 10.1? I have a question. How many of you guys in Math 95 study function notation f of x? That's f of x. If you didn't, you're now learning it right now. That's totally fine. But when you did f of x notation, that's what it is. The f, which is the same as y. What's the y value? What is the y value when x is 10.1? It's 200. So if you take the y value when x is 10.1 and take away from it the y value when x is 5, they're different by 142. Ready for this? Second, enter. Second, enter. So far so good? Now we're going to learn a little trick that comes in handy on a TI sometimes. Use your left arrow key to scooch all the way to the front of that line. To the Y1 parentheses 10.1. Press second delete. You are now what is called insert mode. What I want you to do is to put a left parentheses in front of that by just simply pressing left parentheses now. And what it will do is it'll shove everything else over one spot and make room for the parentheses, and then drop it in. Right there, DEL. Sorry, yeah, DEL is right next to mode. Sorry, delete is DEL. Second DEL. Second delete, put the parentheses in, now scooch all the way to the end, and put a parentheses at the very end.
Another one?
Yeah, because what you're doing is, you're putting the entire thing in parentheses. And there's a reason for this. Some of you might already recognize why we have to do this. If you don't, we'll see it momentarily. If you press enter right now, should you get a different result from the previous one? No. No, and you will not. You will not. But don't press enter right now. That's not the point of what I just did. Now what I want to do is, I want you to put a, anybody predict what we're going to put next? A divide by symbol.
If I press enter, how do I go back?
Press second enter. Second enter gets you that line right back. The second enter trick that I'm showing you guys, how many of you knew it before, the second enter trick? A couple of you did. Second enter is great because it allows you to go back, instead of having to go through all those button pushes again, all you gotta do is pull the line up and then change what you need to change. So it's like Control Z on a computer. This predates Control Z though by a couple decades. Now in the bottom, put the denominator. Now, you can keep track of this in your mind. In other words, you see how we had 10.1 minus 5? You can either put that in or put 5.1 in. It's your choice, really. How would you like to put it in? As a subtraction or just as the number? Just the number? Done. Divide by 5.1. Why do you think I asked you how you want to put it in? If you chose to put it in as 10 minus 5.1, what would you have had to have put first? Left parentheses first. Because the TI would have been confused if it saw two numbers separated by a subtraction sign. It wouldn't know what to do first. But if you just put in the simple number, then it's just 5.1. There's no confusion. It knows what it's going to be doing. You guys ready? Press enter. Does that number look familiar? Hells! Yeah. That's the speed we just did over here. It's all of this math spitting out the number, but it's doing it all for you one by one, yes? Fair enough. Now, the reason the next, somebody asked me about are we doing the C and D and E and F? No, we're about to do that all now, one after the other, because now we've got the template set up. All we've got to do is go in and edit. So you ready? Next question, C. Calculate my average rate of change between the time in B, which is 10.1 seconds, and 2 seconds before that time. Use the TI like we did together, i.e. just now, and include the unit. So you ready? Here's the best part. Second, enter. All we got to do now is go in and edit all of that stuff. Y1 of 10.1, is that going to change? No. That's the finishing point. That's going to stay there. What's this guy going to become? Y1 of? It's going to be 8.1, yes? Yeah. Now, careful. Somebody said 2. I love that answer, by the way. I love that answer. But if you put that in as Y1 of 2, what's the TI going to think you're doing? My average rate of change from 2 seconds to 10.1 seconds, which is actually 8.1 seconds, yes? Yes. I want to get closer to the 10.1, which would be 8.1, yes? 8.1 is 2 seconds behind 10.1. So our job is to change that 5 to an 8.1. May I offer a suggestion? Arrow over to the 5. You can arrow up and then over to get to it, I think. Press 8. That'll overwrite the 5. If you continue to type the 0.1 right now, it's going to mess up a little bit. You're going to erase what you already have. So use that second delete trick again. Second delete, and insert the 0.1 now.
Or you can just keep typing.
Or you can just keep typing, of course you can. You can also overwrite and re-put the things in. That's totally fine, no problem with that. That's okay, you have to retype them then, that's okay. You have to retype them in. But if you use the insert bit, it'll shove over and make room for what you're typing. Just a heads up. The TI is a little bit ass backwards in that, you know how a computer is automatically set into insert mode? For example, if you're typing a Word document and you go back into a Word and you start typing, it shoves everything over to make room for it. And you have to put it in overwrite mode. Your TI is backwards. It's automatically in overwrite mode. You have to change it to insert mode. Pain in the ass? Of course it is, but unfortunately it's stuff. Alright, now what else do we have to change, friends? The denominator has to be changed, doesn't it? To what?
10.1.
It would be, wouldn't it? Wouldn't it be 2? Because remember what I asked. 2 seconds before and 10.1. Well, you could do it 2 ways. You could do it as 10.1 minus 8.1, or just realize it's 2 seconds. So just change the 5.1 to 2, yes? Yes? Everybody okay with this so far? I won't press enter just yet, just to make sure we're still making changes. Well, don't worry. We'll fix the screw-ups. It's all about learning.
How do I get rid of that 0.1?
How do I get rid of this?
Just hit delete.
What 0.1? Oh, yes! So I see what you're saying. I see what you guys are saying. So it was 5.1, yes?
Yeah.
So what I did was, I typed over a 2,
Yeah.
then just delete twice goes away.
Okay.
Thank you. I forgot about that, Joey. Thank you for bringing that up, and thank you, Tony, for answering the question. Fair? How fast was I going over that? 32.8-ish, 32.76 feet per second. Is it faster than it was from 5 seconds to 10.1? That hopefully makes sense, doesn't it, friends? Because that line is getting steeper, yes? It's getting steeper and steeper and steeper. Now, if we go back and look at the graph again, and I do want to do this, I'm going to slide this back over here.
So that's C, right?
That, I think, is C. I'm going to go back and look at it again. I'm not sure now. I can't really remember.
Calculate that.
It's whatever the one was 2 seconds before. I don't know which one that is. Well, I'll come back to it because I've erased it now. But apparently, that now, friends, here's 10, 8. That's this guy, is it? Whoa. That happens at least once a day. The slope of that line right there is 32.8 feet per second. 76, we'll call it 8. That's okay with you guys. So, what I want to do over, I'm going to put it here. I'm going to make a little table. Okay? Time times average rate of change in feet per second. I want to keep track of this. So we're going to keep going back and forth between the picture and the chart. But I want to keep track of where we're going because we might need more board, and I want to make sure we can see all this on the camera. So between 0 to 10.1 seconds, my average rate of change was 19.8 feet per second, yes? From 5 to 10.1 seconds, it was 27.8 feet per second. From 8.1 to 10.1, i.e. 2 seconds before I crossed 200 feet, it was now, what was it, 32.8 feet per second. Now look at the differences in the calculations. How far apart are these guys right here, ish? About 8? Yeah, actually almost exactly 8 if you ignore the rounding. How far apart are these? Less than 8, yes? The difference is going to get less and less. That's because the slopes, although they're increasing, are increasing less quickly the closer we get out to that point. The biggest change was in the initial one to the 5 to 10.1. Now you're going to see the slopes. They're going to keep increasing as we scooch closer and closer, but they're not going to be getting as big as fast. They're going to be getting bigger, but they're going to be getting bigger more slowly, if that makes sense. It's almost like when you throw a ball up in the air. It's always going higher, right up until the point where it turns and comes back down. But in the moments right before it turns, it almost becomes weightless and just hangs there. That's the same idea. It's the same idea as this. The fact that we're honing in on that, if you will, hang point. Fair enough? So we now have the answer, I guess, to part C, yes? Calculate my average rate of change, yes, 2 seconds before. Part D, how about between B and 1 second before? Yes, I think we should. We do the exact same thing we just did, except we go back and edit it, yes? We're back here. I'm going to press clear real quick. Oh, I just did. That's not a problem. Just press second enter. Look, second enter, it's back. There it is. All is well. You don't lose anything. As long as you press enter on the command, that's 32.8. Yes, part C is 32.8 feet per second, yes?
Yes.
Good enough, good enough, good enough?
Yes.
Fair enough. Thank you. Now all I got to do is change some numbers to reflect the fact that it's only 1 second different. Is 10.1 going to change?
No.
Nope. Is 8.1 going to change?
Yes.
What's that going to be? Love it. What's the 2 going to become? 1, because only 1 second different, yes? How fast am I going now?
34.3.
34.3 feet per second. Notice it's faster, but not much faster. So now we're at 9.1 and 10.1, 34.3. See what's happening, friends? Do you see the pattern that's evolving now? Here's what I want you guys to do. I want you guys to either work together or alone and knock out E, F, G, and H. I'm going to turn the camera off. We're going to take some time. We're going to regroup at about 10 and compare notes. Yes, compare notes.